Hi guys, so welcome pa rin sa ating Module 11 entitled Flange Bolt Coupling. So more sample problems tayo class. So start na tayo. Sample number 3. A torque of 700 pound-foot is to be carried by a flange bolt coupling that consists of 8 1/2 inch diameter steel bolt on a circle of diameter 12 inch and 6 1/2 inch diameter steel bolt on a circle of diameter 9 inch. Determine the shear stress in the bolts. Okay? So, drawing muna natin siya. So, ganun ulit no, yung outer bolt circle natin is the same siya ng diameter and then same type ng material nung sa inner bolt circle natin. No? Pareha silang steel and pareha silang 1/2 inch diameter. So, dito sinabi meron daw 8 and then 1/2 inch diameter and then sa loob is 6 naman. Okay. So, same na 1/2 inch yung diameter ng bolt. Okay, pwede na siguro yan. So, still 1/2 inch. And then, binigyan tayo ng mga radius. So, from the center, yung radius ng outer bolt circle is how much? So, ito na lang. Ilan yan, class? R1 equals, binigyan tayo ng 12 inch diameter. So, that is 6 inches. And then, itong inner bolt circle natin. So, meron siyang R2 na equal sa, so, sabi is 9 inch naman siya. So, 4.5 inch ang radius. So, dito class, binigyan na tayo ng torque. And then, yung amount ng torque is 700 pound-foot. So, that is to be resisted by our bolts. So, para sa outer bolt, so magre-resist siya ng P1. So, lahat sila P1. And then, sa inner bolt, magre-resist naman siya ng P2. So, if we recall the relationship ng torque doon sa mga torque capacity ng ating mga bolts, so para sa outer bolts, so that is force times the distance and then times kung ilan sila and then plus force times the distance ng inner bolt circle natin times kung ilan piraso sila. Okay? So, tinatanong dito class is yung shear stress, okay, nung bolt. So, tawagin ko, tinatanong is shear stress nung outer and then ilan yung shear stress ng inner. Okay? So, alam natin class na kapag nag-solve tayo, dapat mas malaki yung magiging shear stress ng outer sa inner. Okay, anyways, substitute natin dito class kung ito ang equation. So, therefore, magiging 700 and then pound-foot. So, kung magiging pound-foot ito, dapat yung force P naka-pounds and then ito is naka-foot din siya. Okay? Okay, so kung pound foot ito, dapat ito pound, ito foot rin. So, anyways, yung P1 wala pa tayo. Yung R1 meron na tayong R1 which is 6 inches. Pero dahil kailangan naka-foot siya, so convert ko siya. So that 1 foot over 12 inches. And then times kung ilang piraso sila. So that is, sinabi is 8. And then plus P2. And then yung radius is 4.5 inch. So convert natin 1 foot per 12 inches. And then kung ilang piraso sila, so that is 6 pieces. So therefore, naka-generate ako ng isang equation involving P1 and then P2. So tawagin ko itong equation 1. Pero ayan, simplify na natin. No? So 700 is equal to, so 6 times 8 divided by 12. So that is 4 P1 and then plus 4.5 times 6 divided by 12. So that is 2.25 of P2. Ito na ngayon yung ating equation 1 relating P1 and then P2. So saan natin kukunin yung next relationship nila, class? E di dun sa relationship nila with respect sa radius nila, no? So since same lang naman sila ng material and then same sila ng diameter, so sabi ko pwede natin gamitin yung P1 over R1 is equal to P2 over R2. Okay, so for P1 ang radius niya is 6, and then dito is P2 ang radius niya is 4.5. Okay, so therefore simplifying this, pwede kong sabihin that 4.5 of P1 is equal to 6 P2. Okay, so therefore ito na ngayon yung equation 2 ko. So 2 equations, 2 unknowns, solvable ang P1 and then P2. So ilan yan, class? Therefore P1, P2, ilan sila? Okay, so input ko sa calculus ko yan, no? Gagamitin ko yung mode 5.1. So 4, 2.25, then 700. Dito 4.5, and then lipat ko to negative 6 tapos 0. So that ang sagot is 123.08. So anong unit? Pounds, class, no? And then ito is 92.31 and then pounds. Okay, so may P1 and then P2 na ako. Ang tinatanong is shear stress. So proceed na tayo. So for outer, so that shear outer is equal sa force sa outer, which is yung P1 over yung area. So that is 123.08 pounds over yung area ng bolt is 5 over 4 times 0.5 inch squared. So pounds and then inch squared, so PSI. So ilan ang shear stress ng outer bolt circle natin. Okay, so sagot is 626.83 and then PSI. Okay, so may sagot na tayong isa. And then for inner bolt circle, so that shear stress ng inner, so that is yung force naman sa inner, which is yung P2, and then yung area nila. So that is yung P2 is 92.31 pounds over 5 over 2 times 0.5 inch squared. So shear stress sa inner bolt is 470.12 PSI. Okay, so yun na po yung sagot. Okay, so check natin, class, kung tama. So 66.83 and then 470.12, so correct. Okay, next. A flange bolt coupling consists of 6 1/2 inch steel bolt evenly spaced around a bolt circle of 12 inch in diameter, and then 4 3/4 inch aluminum bolts on a concentric bolt circle 8 inch in diameter. What torque can be applied without exceeding 9,000 psi in the steel or 6,000 psi in the aluminum? Assume shear modulus for steel 12 times 10 raised to 6 psi, and then shear modulus for aluminum is 4 times 10 raised to 6 psi. Okay, so dito naman, class, is medyo complicated na siya, no? Kasi hindi na siya same type ng material, at the same time hindi na rin same na area yung mga bolts natin. So let's say ayan siya. So dito may 6, na maliliit. And then, dito is merong 4 na aluminum, no? So, lagay ko to. Ito is para sa steel. So, 1/2 inch. So, steel yan. Lagay ko. And then, binigyan tayo ng ano, no? Radius. So, from the center, yung radius ng outer bolt circle natin na tinatawag natin R1 is 12-inch diameter, so therefore 6-inch ito. Okay, and then for the inner bolt circle naman, so sinabi ito is alum na 3/4 inch in diameter, and then meron siyang radius na R2 na equal saan? So sinabi is 8-inch in diameter, so therefore 4-inch. Okay, so binigyan din tayo ng shear modulus, no? So G neto still is 12 times 10 raised to 6 psi. Dito G alum is 4 times 10 raised to 6 psi. Okay, ano pang binigay class? Binigay din tayo ng allowable shear stresses, no, ng material natin. So for steel, allow neto para sa steel is 9,000 psi. And then dito, allow ng aluminum is 6,000 psi. So, kung dito is magkakaroon ng torque T, therefore, mag-offer ng resistance ang ating mga bolts. So, therefore, ito is P1, and then dito sa loob is P2. Okay, so to solve for the total torque capacity, that is P1 R1 N1 plus P2 R2 and then N2. So, may mga radius tayo, may number of pieces tayo, so siguro pwede natin i-substitute. So, T is equal sa P1 and then radius is 6 inch and then times 6 pieces plus P2 times radius nila is 4 inch and then that is 4 pieces. Okay, so therefore meron na akong equation relating yung torque na hinahanap doon sa mga force carried by the steel and then the aluminum bolts natin. So ngayon plus wala pa tayong value nito, di ba? So saan natin kukunin yan? So siguro bigyan pa natin sila ng relationship using yung ano, no, yung general formula that P1 over A1 G1 R1 is equal to P2 over A2 G2 R2. So bakit ito ginamit natin? Since hindi na kasi sila same type na material at magkaiba na rin yung cross-sectional area. So doon tayo sa general. Okay, so P1 over area is pi over 4 times ang diameter niya is 1/2. So 1/2 inch squared, and then yung G is 12 times 10 raised to 6 psi. So habaan ko lang. And then yung radius niya is 6 inch. Okay, and then dito is P2 over pi over 4 times the diameter ng bolt is 3/4 inch and then squared, and then times yung G 4 times 10 raised to 6 psi, and then 6 ilan yung ano radius nito? 4 inch lang. Okay, so 4 inch. Okay, so cancel na natin to para ma-simplify. So ilan yung class? So substitute mo na natin, calculate natin yung mga constant. Okay, papagsamahin ko na siguro ito class ha. So magiging ano, P1 is equal to, so lilipat ko to doon, 0.5 squared times 12 times 6 divided by 0.75 squared times 4 times 4. So sagot is 2. Okay? So, 2P2. O ngayon class, pag nilipat ko dun, wala pa rin value, di ba? So, kailangan saan ko kukunin ulit tong force carried by the bolts natin. E di doon sa mga allowable shear stresses nila. No? Kunin natin yung capacity nila, tapos hanapin ulit natin kung sino sa dalawang material ang unang magfe-fail or unang makaka-reach ng capacity niya. So, sa case na to, hindi na natin sure kung yung outer bolt yung unang magfe-fail since hindi naman sila same ng material. So, ngayon, ta-trial and error tayo. No? Try natin case 1 na siya yung mauuna, and then try natin yung case 2 kung ito bang nasa loob yung mauuna. Okay, so bago yun, kunin natin yung capacity nila. So, for steel, so, tau allow steel is equal sa P steel over area ng steel. Okay, so, this one is 9,000 PSI. So, P steel capacity over area niya is pi over 4 times 0.5 inch squared. So, ilan ang allowable force na pwedeng carry ng steel? That is 1767.15 and then pounds. Okay, how about naman for aluminum? So, allowable ng aluminum is equal sa force ng alum over area ng alum. So, that is 6,000 PSI equal sa capacity ng aluminum over area ng aluminum. So, that is 3/4 squared. So, inch ito. So, ilan yung P alum? Okay, so sagot is 2650.72 pounds. Okay, pero hindi ilalagay natin ha. Hindi ito yung P1, hindi ito yung P2 kasi nga hindi niya naman masasatisfy itong equation na to. So magta-trial and error tayo. So sa tingin mo sino unang fail diyan class or unang makaka-reach ng capacity niya? So try natin na si steel ang una. So case 1, steel fail first. Okay, so kung siya yung unang mag-fail, so dapat yung P1 must be equal sa P steel na equal sa 1765.15. Tapos, dapat yung P2, which is yung aluminum, so dapat siya is mas mababa pa dito sa capacity niya, which is yung 2650.72 pounds. Okay, so using yung relationship na to, P1 is equal to 2P2. So, palit ko to dito. So, maging 1765.15 is equal to 2P2. So, ilan ang lalabas na P2? So, that is 883.57 pounds. Okay? So, nasatisfy ba natin yung yung condition natin? So, si P1, nilagay natin siya sa limit niya, sa capacity niya, sa maximum allowable na pwede niya i-carry. While si P2 is hindi pa nga siya umaabot dun sa capacity niya, no? Hindi pa natin masyadong nai-stress si aluminum. So, therefore, class, correct ang assumption natin. No? So, this one governs na. So, hindi na natin kailangan i-check yung case 2 na unang nag-fail yung aluminum kaysa kay steel kasi ito na yung tamang condition. Okay, so therefore, class, ang gagamitin nating actual values ng P1 and then P2 is ito yung limit niyang 1765.15. Itong P2, so ito lang yung niya, i-carry niya yung sa actual condition. So 883.57 57 pounds. Okay, so meron na akong P1 sa P2. So, palit ko na yan dito para masolve yung torque capacity. So, that T is equal sa 1765.15 and then pounds and then 6" times 6 plus yung P2 883.57 pounds times 4" and then times 4. Okay, so using this, masolve na natin yung T. So ngayon, therefore, ilan ngayon ang torque capacity using yung mga values na yan. So, calculate natin. So, lumabas sa calculate ko is 75754.42 and then the unit is pound-inch. Okay, so ito na ngayon yung sagot. So, let's check class kung correct. So, 77754.42 pound-inch. So, correct siya, no? So far, ito na yung pinakamahirap na sample problem natin regarding sa topic ng flange bolt coupling. Okay, and then, for the last problem, so a plate is fastened to a fixed member by 4 20 mm diameter rivets arranged as shown in the figure. Compute the maximum and then minimum shearing stress developed. So ito class, nagmukha lang siya mahirap, no, kasi hindi napabilog yung flange bolt coupling natin. Pero class, yung analysis nito, parehas na parehas lang. Okay, so and first thing to do is draw muna ulit natin siya. So let's say ito siya. Okay, so compose siya ng apat na ilang diameter nito class. So diameter 20 mm. So yung distance nila is 80 mm. And then may pinakita dito class na mga couple, no? So alam natin class, kapag may couple, makaka-generate yan ng moment. Okay. So makaka-generate siya ng moment, which is torque yung magiging effect niya dito sa mga bolts natin. Okay, so paano ba ma-analyze to class? Yung tinatanong is yung tau max and then yung tau minimum. Okay, so ang analysis nito class, kunin muna natin yung magiging moment nito or yung torque niya. So that yung torque is equal sa force times the distance, so that is 14 kilonewton, and then times yung distance niya is 240 mm. So, yung equivalent torque niya ng couple niya is 3360. Then, the unit is kilonewton mm. Ngayon, class, paano i-resist ng mga bolts natin yan? So, imaginein mo, dito, may bilog dito. So, ito yung magiging outer bolt circle natin. And then, ito naman yung inner bolt circle. Okay? So, parang may imagine mo, parang may bolt circle pala ako na consisting ng 2 bolts. And then, may isa pa, yung inner bolt circle naman consisting of 2 bolts. So, mas mangyayari dito, sino yung analysis, no, yung ginagawa natin before. So, kukunin natin yung center. So, may radius inner, tapos may radius outer. So, ito yung inner radius, which is R2 yan, di ba? Ilan yung class? So, kung 80 to, so therefore that is 40 mm. And then from the center, ito naman yung radius ng outer bolt circle natin, which is R1. That is 40 plus 80, 120 mm. Okay, so paano mag-resist yung bolt? So kung pa ganito yung moment, so therefore mag-resist sila ng pa ganito. So therefore ito is pataas na yung direction niya. So ganun din dito. Pababa naman, no? Para maka-generate siya ng couple naman na nire-resist itong direction ng applied load. Tapos dito meron din. nakapaganyan. Okay, so ito yung mga P2 natin. Kasi ito naman yung mga P1 natin. Natabunan na. Pero ganun yung class. Okay, so relating yung torque sa mga forces carried ng bolts natin. So that is, torque is equal sa torque capacity ng outer bolt circle, which is force times the distance, and then times kung ilang piraso. And then yung inner bolt circle, which is force times the distance, and then times how many pieces. So, ito nakuha na natin. So, 3360 kilonewton mm. So, equal sa P1 wala. Radius 1 is 120 mm times 2 pieces plus P2, and then R2 is 40 mm times 2 pieces. So, simplifying, so 3360 is equal to 240 of P1 and then plus 80 of P2. But take note class, dahil ito is naka kilonewton mm, so therefore ito dapat naka kilonewton tapos ka-partner is mm para same ang unit natin. Okay, so yung masasabi natin P dyan naka kilonewton. So therefore naka-generate tayo ng equation 1 relating P1 and then P2. So saan pa yung next class? Edi yung relationship naman nila using yung radius, di ba? So since same naman sila ng diameter, same sila ng bolt na material na ginamit, so pwede kong gamitin that P1 over R1 is equal to P2 over R2. So magiging P1 over 120 is equal to P2 over R2 na 40. So simplifying this equation, magiging P1 is equal to 120 over 40, so 3 P2. So ito ngayon yung equation 2. So 2 equations to unknown, solvable ang P1 and then P2. So ilan sila class? Open tayo sa calcu. So lumabas sa akin that P1 is 12.6 kilonewtons and then P2 is 4.2 kilonewtons. So may force na tayo, makuha na natin yung mga stress. So therefore maximum yung stress syempre sa outer pa rin, di ba? Tas minimum dito sa inner bolt circle. So for tau max, so that shear stress maximum is equal sa yung force sa outer bolt circle over yung area. So that is 12, gagawin ko ng newton, so 12,600 newton over area is pi over 4 times the diameter, 20 mm, and then squared. So tau max now equals okay, so sagot is 40.11 and then MPa. And then for minimum shear stress, so that is sa inner bolt circle, so tau min is equal naman yung sa P2 over yung area niya, so that is 4,200 naman newtons over pi over 4 times 20 mm squared. So ilan ang tau minimum? Okay, so sagot is 13.37 MPa. Okay, so ganun lang siya, no? So intimidating lang siya tignan, pero once na na-imagine mo na siya paano siya nag-work, paano niyang nire-resist yung torque, so same lang ang solution. Okay, so let's check kung tama ang ating sagot. So 40.11 MPa and then 13.37 MPa. Okay, so hanggang dyan na lang class yung topic natin na flange bolt coupling. So sana nag-guess nyo. So hanggang dyan na lang class. So thank you guys for watching and God bless.